Hi folks. So let's try to learn Scala. I have googled up Scala and this apparently is its main home on the web. All right, let's see what does it say. Scala combines object oriented and functional programming in one concise high level language. Scala's static types help avoid bugs in complex applications, and its JVM and JavaScript runtimes let you build high performance systems with easy access to huge ecosystem of libraries. All right, so what is it saying? Scala, as you know, is really gaining traction a lot, and that must be for good reason. So it is object oriented and also supports the functional programming paradigm. It has static types, which means it is a strongly typed language, catches thing at compile time to the degree possible, and it has a Java virtual machine as well as a JavaScript runtime. So what does that mean? That means you can cross-link into other code which is accessible through JVM, which is any Java code, Java code that exists in the JVM in the form of bytecode. And in addition to that, the JavaScript runtime also exists. So you can use mix and match with JavaScript runtime as well. That's interesting. So that gives access to huge ecosystem of libraries, right? There are tons of Java libraries and even JavaScript libraries now. So they're all accessible from this new programming language. Okay, that is clearly something that sounds interesting, and let's explore it further. Okay, what does this say? So this is the download, the API documentation. All right, what else? Scala runs JavaScript, JVM. What is this? Natively with LLVM, the tool chain, LLVM compiler tool chain. Okay, so Scala in a nutshell. Let's see what does Scala do in a nutshell. Seamless Java interop. We've already discussed this, right? Type inference. So the type system does not feel so static. All right, so this is interesting. On the one hand, they're saying that it is static. On the other hand, it is also saying that it can infer type, even though if you do not specify it. So that's sort of a multi-paradigm. We'll explore this. Concurrency and distribution. Use data parallel operation on collections. Use actors for concurrency and distribution, or futures for asynchronous programming. So it has native abstractions and entities that help in parallel and distributed computing and asynchronous programming paradigm. Traits combine the flexibility of Java style interfaces with the power of classes. Think principled multiple inheritance. Okay, we'll see that. Pattern matching. Think switch on steroids. Okay. Match against class hierarchies, sequences, and more. We'll see. Higher order functions. Functions are first class objects. Compose them with guaranteed type safety. Use them anywhere. Pass them to anything. Interesting. We'll see. Let's see. We can click on the learn more part. And let's see what else is here. So IDEs, there is a commercial IntelliJ. VS Code is free. GNU Emacs, Vim, Sublime Text. All right. Run Scala in your browser. Scasti is Scala plus SPT. What is an SPT? In your browser, you can use any version of Scala, or even alternate backends such as .t, this. You can use any published library. You can save and share Scala programs and builds with anybody. It does sound like an interesting thing. We'll explore it later. Okay. Online courses, functional programming principles in Scala, functional programming design and functional program design in Scala, parallel programming. These are all free and these are in on Coursera, or so it seems, except this last one, programming reactive systems, which is on both Coursera and edX. All right, so we don't want to go through that. There are events. All right. There is the Scala ecosystem. The Scala Library Index or Scaladex is a representation of a map of all published Scala libraries. With Scaladex, a developer can now query more than 175,000 releases of Scala libraries. Interesting. It is officially supported by the Scala Center. So yeah, that is useful. What else? Okay. Okay, talk to us. Scala users, contributors, real-time chat. There's their Twitter feed, and it's maintained by some folks, and it is supported by some other folks. Okay, so this is interesting. Let's go back on the top and let's close this and let's go to the documentation. We were looking at this. Okay, so there are multiple guides and documentations. Let's see what is out there. So first steps, getting started, a tour of Scala, and then there's a Scala book. All right, this looks like a good thing. This also looks good. Online courses, exercises, and blogs. We'd want to see the exercise and blogs and also the books. Returning users, there is an API documentation, cheat sheet, overviews, FAQ, style guide, and the formal spec. We'll might have to consult these once we get started. There's its evolution, and Scala 3 is apparently the new version or something. We're not interested in having a look at that. Okay. So let's see what online resources is it mentioning. From the Scala Center, these are the same courses we just saw. Scala exercises seems like a good thing. So let's see what is this. So there is some Dr. Mark C. Lewis from the Trinity University in Texas. He teaches programming courses and they're available on the YouTube for free. Interesting. Scala Learning Community on Discord, the chat service. Okay, what else? All About Scala provides detailed tutorials for beginners. This might be a good thing. Independent courseware, an online self-study or instructor-led Scala and play courses for a fee. Dev Inside You, Visual Scala Reference, a guide to visually learn. Let's see what is this. Okay, what else? What else was there? We've seen this. Okay, so the path to enlightenment. Scala Exercises is an open source project for learning different technologies based in the Scala programming language. Okay, so this seems like a good thing. We'll probably go through all of that. Okay, uh, this looks good. So let's keep this open and move to the next guy, which is the Scala tutorials, all about Scala. Okay, Scala for beginners, machine learning with Scala, tutorials, general overview, blah, 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 blah. These seem good. Okay, what else? Scala introduction, chapter one, this. Okay, so it looks like that book that is available is completely here online for free, right? Okay, so let's see. Let's let's see anything at random. Mm, let's say this. So what does this guy say? Beginner's tutorial 2. So it is trying to explain something all about Scala, blah blah blah. Okay, so this is something that we could possibly explore, and let's see what else. Visual Scala reference. This guide collects some of the most common functions of Scala and explains them conceptually and graphically in a simple way. So let's get a feel of this. Let's say scan right. What does this do? Create collection, blah blah. Creates a collection with immediate results. Okay, so this it has tried to visually show it to us. Okay, not really a big deal. What else? So drop while. Let's say, what does this say? Yeah, we're not really this dumb, so we can do without it as well. Uh, okay, so just a moment. Let's close this. We're not interested. Let's also close this. All about Scala. We'll see if it matters to us. So there are these Scala books, hands-on Scala, programming in Scala, blah blah blah. So we don't care here about this either. All right, so let's close this. So the Scala exercises might be useful. Let's keep this open. So getting started. Let's get started. All right. Uh, okay. So try Scala without none. We want to install it properly. Okay, download and execute the Scala installer based on Cursia, along with managing JVM that also installs useful command line tools. This. I have the Java JDK installed, and let's let the installer tool uh, do its job. All right. So where is the installer tool? CS Scala installer for Windows. So let's download this and install it. All right. So while it is trying to get downloaded, let's say after this, we'll create a Hello World project. That should be good. And we'll set up VS Code. All right. And then we'll try to compile it. And there is the so-called the Scala book. This seems their official Scala book or something. We could consult it. Yeah. So this is good. So we'll okay. So there's the Scala book, Tour of Scala. What is the Tour of Scala? Getting help. All right. Scala exercises was another one. Not the book. Where did that other URL go? It's over here. So this is the tour. Yeah, this seems good. So after the Hello World program, we'll uh, we'll have a look at this tour. All right, to get an overview. All right, so this guy is about to be downloaded. Let's install it. Mm, why is it's not letting me install it? Okay, let me try to run it as the administrator. Hmm. Okay, run it anyway. Okay. So for some odd reason, Windows Defender thought that it is a risk, but since it has come from official path, official website, so we can trust it. All right. So what is it saying? It found the JVM. It wants to add its Scala thing into its path. Okay, do it. Now it's going to install its Scala applications. It's downloading them. So see, it's downloading the jar file. So it's heavily linked to the Java JVM oriented ecosystem, right? We'll keep on exploring this. This much I knew already, but we'll go hands on. All right, till this is downloading, let's try to read about it. Should we do the tour first or should we do the book first? Okay, where did the book go, by the way? On the book. Where did the book go? Let's see, where did the book go? I think this is the book. Okay, this is the Scala book. Okay. In these pages, Scala book provides a quick introduction and overview of the Scala programming language. The book is written in an informal style, consists of more than 50 small lessons. Each lesson is long enough to give you an idea of the language features in that lesson work, but short enough that you can read it in 15 minutes or less. Precisely our type of thing. In regards to programming style, most Scala programmers indent their code with two spaces, but we use four spaces because we think it makes the code easier to read. All right, who cares? You could always use a code formatter to do it, transform it either way. To begin reading, click the next link. Okay. All right. So our hope in this book is to demonstrate that Scala is a beautiful, modern, expressive programming language. To help demonstrate that in this first chapter, we'll jump right in. Okay. We assume that you've used a language like Java before and are ready to see a series of Scala examples to get a feel for of what the language looks like. Although it's not 100% necessary, it will also help if you've already downloaded and installed Scala, so you can test the examples as you go along. All right, so yeah, that is in process. Let's see what happened of it. Uh, it's downloading things. All right, so okay. So first the overview. Before we jump into the examples, here are a few important things to know about Scala. It's high-level language. We know that it's statically typed, yes, but there is some kind of dynamic inference as well. We'll see. Its syntax is concise but still readable. We call it expressive. Good. It supports object-oriented paradigm. It supports the functional programming paradigm. It has a sophisticated type inference system. So if you see this feature and this feature, the statically typed and they are competing considerations. It will be interesting to see how they have done it, right? On one hand, it is statically typed, and on the other hand, it says it has a sophisticated type inference system. Okay, Scala code results in .class files that are on the Java virtual machine. Yeah, okay. It's easy to use Java libraries in Scala. Okay, sure, good. Ever since the book C programming language, it's been a tradition. Yeah, we know Hello World. So what does it do? So okay, object hello extends app and print line hello world. Okay, so after you save that code to a file named this, you compile it with the Scala compiler, Scala C, blah blah. Scala C is just like Java C, creates two things: hello dollar dot class and hello dot class. Those are the same dot class bytecode files that you create with Java C, and they are ready to run in the JVM. Good, good. So this should just work. Uh, okay. So the download is happening and we can read further. The Scala REPL, read, evaluate, print loop, is a command line interpreter that you use as a playground area to test your Scala code. Yeah, it's typical. We introduce it here early, blah, blah, blah. Start, just type Scala at your operating system command line and you'll see something like this. Type in expressions for evaluation. Okay. Because the REPL is a command line interpreter, it just sits there waiting for you to type something. Inside the REPL, you type Scala expressions to see how they work. Well, x is equal to 1, so It shows you what it has done. It has assigned integer is equal to 1 to x. Val y is equal to x plus 1. So y is integer equal to 2. Okay. All those examples show after you type your expressions in REPL, it shows the result of each expression on the line following the prompt. The result only, not how it has reached that. For example, over here it would have done, this increment operator, it would have then assigned this into y, two steps, right? So over here it has just showed us the result. Okay, the two types of variables that are there, what are they? Scala has two types of variables. Val is an immutable variable like final in Java and should be preferred. Var creates a mutable variable and should only be used when there is a specific reason to use it. All right. So a mute an immutable variable is defined by defined by the keyword val prefixed to the name of the variable, and a mutable one, when we have a good reason to use it, is defined using the keyword var. Okay, so declaring the types of the variables. In Scala, you typically create variables without declaring their type. Now, this is interesting. For example, val x is equal to 1, val s is equal to this is a string, val p is equal to new person, some class initialized by the parameter to its constructor, Regina. When you do this, Scala can usually infer the data type for you as shown in these REPL examples. Yeah. This feature is known as a type inference, and it's a great way to keep your code concise. You can also explicitly declare a variable's type, but that's not usually necessary. Now, this is interesting. So it's not really a strongly typed language. Uh, so value x int equal to 1. Value this is immutable, right? S is a string and assigned a string. P is a person and assigned a class which has been dynamically allocated using new. Okay, so as you can see, the code looks unnecessarily verbose. Verbose, yes, unnecessarily, not sure, we'll see. Uh, okay, so clearly this is less verbose, but it sort of dumps down the programmer, over here, of course, I mean, it's clear that I'm creating an instance of a class named person, so the type is pretty clear. But over here, for example, uh, I could have meant anything. I could have meant the integer one, the floating point 1.000, or uh, how did it really infer from this? So let's see how it sorts these things. So there are control structures. Here's a quick tour of Scala's control structure. There's a conditional if else. This is very typical like the C style. If test one, do A, else if this, and finally there is an else. All right. However, unlike Java and many other languages, the if else construct returns a value. Oh, this is interesting. So amongst other things, you can use it as a ternary operator. So val x is equal to if a is less than b, a else b. Okay, so and this entire expression on the right hand side would also return depending on what this condition happens to evaluate to either a or b, and that in turn is assigned to x. This is interesting. So match expressions, Scala has a match expression with which in its most basic use is like a Java switch statement. So yeah, Java switch is also more or less like the C++ switch. Let's see. Okay, let's have a look at our installation. Okay, so this is installed. Let's press enter. What happened? I think it's done. All right, so let's open a terminal window and let's try to see if Scala C is available in the path. Its version. Yeah, it is. It is installed. And now let us see what was its REPL. Scala. So if we just write Scala, then its REPL thing will start. Okay. So the Scala interpreter is here. It will just show us its prompt in a while. Okay, it's here. Okay, so let's say help. It has tons of help available. So let's say val x is equal to 1, val x string 1. Okay, so let's say val x is equal to 1 integer. Let's say val x is equal to 1.1. Oh, sorry, is equal to, it's a double, it has inferred. Um, Interesting. So let's say we do a var type, var y is equal to 9. All right. So if x is less than y, uh, if x is less than y, then x or y. What was the syntax? Where did it go? There was something about its if conditional, right? Uh, 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 we just saw it, right? Where did it go? Control structures, yeah. If this A else B, okay. X else Y. Okay, so while this has returned the result which is double. So X contains 1, 1 is not, sorry, 1.1, 1.1 is not less than 9. So it has returned Y and Y is 9. So, no, sorry, X, what is X? Yeah, X is less than 9, 1.1 is less than 9, so it returns X. And X is 1.1, which is a double. And that is the value this expression has returned. So this is a good playground, sort of, to see how its expression evaluates things. Uh, that is good. All right. So let's move forward. Okay. So this is the book. Let's keep this. We were over here at the match expressions. Let's pause here and go back to running the Hello World program. Okay. So let's go back up over here. We installed Scala. Let it show. Okay. SBT is a build tool, compiles, runs, and tests all, and also published libraries. SBT new Scala Hello World. This pulls the Hello World template from GitHub. It will also create a target folder which you can ignore when prompted. Name the application Hello World. It will create a project called Hello World. Interesting. So what is this SBT thing? Okay, so let's create a folder. Let's exit from here. Exit. Quit. How does so quit. Okay, so projects. So let's make a folder. Okay, by the name of Scala projects. Scala projects, and we use this SVT thing. This is the command it wants us to run, and let's run that. Let's see what does it do. So this is trying to uh, get that SPT, whatever that is. Okay, so let's say if we reduce this and we go back to the book again. Okay, because they will probably know when this installation is done. Let me move this to the other monitor and we'll see how this is proceeding. When it comes back, I'll let you guys know. Okay, so let's go back to match from the Scala book. Okay, value result is equal to I match case. If I matches with 1, then this will return 1. This matches with 2, return 2. Case underscore not 1 or 2. So it just seems like the default. The match expression is not limited to just integers. It can be used with any data type, including booleans. Okay. So val boolean as string is equal to bool match case true. Mm, okay. So this bool, whatever its value is, if it's true, then the string true will be returned, and if it's false, then the string false will be returned. All right. So here is another example of match being used as the body of a method and matching against many different types. So we define a function which takes any parameter and returns a string. Okay, where x matches and the x match uh, x match body says something, but where does this function end? Where is the ending of this function? Uh, okay, we'll see that later. So, okay, if case is S, okay, if case is S, what is it doing really? How does it know? So this would have some special meaning, right? Si uh, get class S string. So I don't know what is it trying to do here. I mean, is it expecting a character here? Probably not. Probably this case over here is interpreting these characters as something else through some other mechanism. But what it is doing is that if it happens to be a string, then it concatenates s with this string is a string, and in case it finds an int, then it generates a string int, so on and so forth. All right. If it's a class person, then it gives this. Okay, so powerful match expressions are a big feature of Scala, and we share more examples later. Okay, we'll see that. Try-catch, Scala's try-catch control structure lets you catch exceptions. It is similar to Java, but its syntax is consistent with match expressions. Okay, so there's this try block. Something happens, catch, case, this file not found exception. What do? You print the exception to the line. Okay, or if case this, if it's an I exception, you print the exception to the line. Okay, so yeah, the syntax is a bit different, but we'll dwell on that more. This is just an overview anyway, right? So for loops and expressions, Scala for loops, which we generally write in this book says for loops look like this: for this println x to y syntax. For I is equal to 0 to 5. For I is assigned 0 to 5. Print line the index I. Okay. X to y by syntax. For I assigned 0 to 10 by the increment 2. So the default increment here would be 1. Over here you define the increment. So the assignment operator over here is instead of the equal to sign, it is this sign basically. All right, you can also add the yield keyword to for loops to create for expressions that yield a result. Here's a for expression that doubles each value in the sequence 1 to 5. Okay, val x is equal to for loop. I is assigned 1 to 5, and its final yield, I mean, there's no body basically. It seems there's no body of this for loop. So this just keeps on looping, but when it exits, it yields I into 2. So what x would be giving 10 only, or would this run this? Is this the body of the loop? I don't know. We'll see that. But if it is indeed the body of the loop, then that yield, uh, how is it assigned over here to this value x? Okay, we'll see. I mean, how is it assigned each time to this value x in each iteration? And if it is, then in the next iteration, except the last, the value is run over, right? It's then what for? So we'll see. Probably I'm not understanding some of its syntax correctly. We'll see. Here's another for expression that iterates over a list of strings. So there's a value fruits, there's a list of strings, value fruit length is equal to for. Okay, so let's see. I noticed an interesting difference. Over here, this for loop, the parentheses are used, but over here, the curly braces are used, right? Let's see what did it use over here. Over here too, parentheses were used. Okay, so over here the curly braces are used. So what is it doing? For yield f dot length. Okay, assign fruits to f if fruit length is greater than 4. uh, I don't know what it is. What is it doing? I mean, this we need to formally see this because gen Scala code generally just makes sense. It doesn't make sense to me at the moment. It is very different to the kinds of for loops that I'm used to. We'll imagine that you can guess how this code works even if you've never seen a for expression or Scala list until now. There's a little confusion which we can probably resolve in the formal definition. So let's keep going. Scala also has a while and do while loops. Here there's syntax while condition statement A B, typically like C, C++, or Java, and same go holds true for the do while loop. All right, so there are classes. It's an object-oriented language. Here's an example of a Scala class person. And what is this? Is this a constructor being defined or is it a class being defined? So variable first name, which is a string, variable last name string. Define print full name. Seems to be a member function, and it prints first name and the last name. Okay, this is how you can use that class. Value b is equal to new person, Julia and Kern. Okay, so where did we even define what is really going on? I mean, by virtue of doing this, are we automatically defining the member's first name and last name automatically? Because this seemed like a constructor or something. So we'll see. Okay, print line p dot first name, p dot last name. You reassign it to something else. P dot print full name. Notice that there's no need to create get and set methods to access the fields in the class. Yeah, so this is a breakage uh, of the setter getter pattern. So there must be a good reason for that. We'll see as we explore further. Let's go further. So there's a class pizza, and it has the definition ends here. It has variables crust size, crust type, toppings, which is an array buffer of. Okay, and what is this doing here? Where is this curly brace ending? It is ending here. Okay. So we define add topping 3 member functions. What does this do? It adds topping by t, internal toppings variable by t. This subtracts by t. Remove all toppings dot clear function. So toppings is an array buffer which must have its own clear function. So yes, let's see. In that code, an array buffer is like Java's array list. The crust size, crust type, and topping classes are not shown, right? So yeah, this is a class. But but you can probably understand how the code works. Yeah, a bit, quite a bit. Okay. So let's move further. Okay. Just like other loop languages, Scala classes have methods, and this is what the Scala method syntax looks like. Define, sum, this, and this is its implementation. Okay. Define concatenate, and this is its implementation. You don't have to declare a method's return type, so it's perfectly legal to write those two methods like this. Define sum, this, so over here it's not declaring the return type, but Scala system is likely inferring it through this implementation, that since it's adding two integers and the result of adding two integers is also an integer, so the return type is automatically an integer, right? So, okay, so how do we call these methods? Value x is equal to sum of 1 and 2, concatenate bluff 1 bar, all right. Okay, so there's something called traits. Traits in Scala are a lot of fun, and they let you break your code down to small modular units. To demonstrate traits, here's an example from later in the book, given these three traits. All right. So what is this? A trait called speaker defines speak string. Has no body, so it's abstract. Okay. Trait tail wagger defines start tail. Unit is equal to print line tail is wagging, stop tail is stopped. Okay. Trait runner defines start running, stop running. Okay. So what are these traits? They seem to be like collections of related methods. Is that what it is? We'll see. You can create a dog class that extends all of those traits while providing behavior for the speak method. So we have a class dog name string extends speaker, which was the abstract base class speaker, with tail wagger, with runner. All right, and define speak. You give it the speaker implementation. So yeah, it gives you a mix and match of extending from classes, and in addition to that, so so to say, copying predefined collection of methods under a single name into the class definition. That seems to be what trait is actually doing, right? Okay. All right. So similarly, here's a cat class that shows how to override multiple trait methods. There's a class Kate that extends speaker with tailwagger with runner, defines speak meow, override. Now it's overriding the start unit method, and start running method is in the trait runner. All right. Okay. So what is the meow doing? Yeah, I don't. So yeah, it is overriding the default method from the which was defined in the class by virtue of copying it from the trait. Okay. If that code makes sense, great. You're comfortable with traits. Yeah, it makes sense. Okay. Collection classes. If you're coming to Scala from Java and you're ready to really jump in and learn Scala, it's possible to use the Java collection classes in Scala. And some people do so for several weeks or months without getting comfortable. No, I'm not from a Java background, so I don't really care. But it's highly recommended that you learn the basic Scala collection classes. Okay. List buffer, vector, array buffer, map, and set as soon as possible. Yeah, why not? A great benefit of the Scala collections classes is that they offer many powerful methods that you'll want to start using as soon as possible to simplify your code. Okay, so populating lists. There are times when it's helpful to create sample lists that are populated with data, and Scala offers many ways to populate lists. All right, there's value nums is equal to list.range. It creates a range list called nums, and from the range 0 to 10. So does it populate with the values or what? Nums 1 to 10 by 2 by increment of 2 and convert to list. So this would contain 5 members, I guess, because the increment is by 2. Value letters is equal to characters A to F to list. So this will contain A, B, C, D, E, F. Value letters A to F by 2. So this will skip 1. So this will contain A, C, D. No, no, not A, C, and E. Yeah, that is what this should contain if I understand it correctly. All right, so sequence methods, while there are many sequential collection classes you can use, array buffer, vector list, and more, let's look at examples of what you can do with the list class. Given these two lists, value name is equal to 1 to 10 dot to list, named list of strings. This is the for each method, okay? Names dot for each print line. Okay, so it will print line. It apparently what it will do is that it will call the print line function in each iteration of traversing this list, right? And yeah, that's what it seems to be doing. All right, here's a filter method followed by for each. Nums dot filter for each. One, two, three. So what does this say? It says that its index is less than 4. What does it want to say? I don't know what it want to say. Okay. Here are some examples of the map methods. While doubles is equal to nums dot map underscore into 2. So there's doubles, which is a list of integers. What it is trying to do, it's creating a list over here. Uh, okay. Well, capital names dot. No. This is it is showing you over here. Okay. So it has a list. Mm, but why did it stop at 20 here? Well, less than 5, nums.map less than 5. So I think this is just filtering. I don't know what the hell is this doing. We'll explore more. Okay, even without any explanation, you can see how map works. It applies an algorithm you supply to every element in that collection. Yeah, this much is clear. Returning a few transformed value for new transformed value for each element. Yeah, that's clear. If you're ready to see one of the most powerful collection methods, here is fold left. Nums.fold left. Uh, I don't know whatever the hell is it doing. Once you know that the first parameter to fold left is a seed value, you can guess that the first number yields the sum of the numbers in nums, and the second example, first example yields the sum of the number in nums. Ah, interesting. That the second example returns a product. So it has sort of inferred our intent from this collection methods has by interesting. Okay, there are many more methods available to Scala collection classes, and many of them will be demonstrated in the collections classes that follow. Yeah, it does give an example of the idea of their power. Okay, tuples. All right. Tuples let you put a heterogeneous collection of elements in a little container. Tuples can contain between 2 and 22 values. Well, interesting. Why between 2 and 22? What's special with 22? Okay. And they can all be different types. For example, given a person class like this, you can create a tuple that contains 3 different people like this. Value 2, this is T is a tuple, and it is the first member is 11, the second is string 11, and third is a instance of the class person. You can access the tuple values by number t dot underscore r. This is the index. Well, not exactly an index, but sort of an index of the tuple. Okay. Or assign the tuple fields to variables. Value number string person. Just a moment. Value number. Okay. What is it doing over here? This is defining this tuple, but without a name. What is the name of this value? I mean, this is its composition, but but where is the name? So I think this will be answered later. Okay. What we haven't shown: strings and built-in numeric types, packaging and imports, how to use Java collections, how to use Java libraries, how to build Scala projects, how to perform unit testing, how to write Scala shell scripts, map sets and other collection classes, object-oriented programming, functional programming, concurrency with futures. All right, so we do get a good background. Okay, Scala was created by Martin Odersky, who studied under Nicholas Wirth, who created Pascal and several other languages. Mr. Odersky is one of the co-designers of generic Java and also known as the father of the Java C compiler. All right, sounds good. Okay, so we'll pause this here and we'll see that. Okay, so this what we were doing over here in the overview. This is done. So it has installed a bunch of stuff and it has downloaded the Hello World template, right? Okay, so what to do with it next? Just a moment. Okay, what does it say? Uh, Prompted. It did not really prompt me. Okay. Okay, so this main.scala. Okay, there is the source directory. There is this main, and we have a Scala directory, and there is the main.scala. Is it a file? Yes, it is a file. Let's try to open it. Object main extends amp, print line, hello world. Okay, so let's try to run this. Scala C, main.scala. Let's see what does it do. Okay, so if we see, it has created two classes, main dollar dot class and main delayed init body dot class and main dot class. Okay, and how do we run it? Ah, okay, what is this guy? CD into hello world. Wait, where is the hello world? What is it saying? CD into hello world. Open a terminal. Okay, so this class file is generated. So let's say if I try to run this using Java, main dot class, oh, Java main dollar dot class. As you can guess, I'm not really a Java guy. So we'll stop this here, and we'll keep on exploring this further. We have got a good, we've installed Scala, and we've got a good introduction. We'll continue the lesson later. We'll keep on exploring this later.